Hey everyone, and welcome back to the channel. Before we begin here today, please make sure that you like and subscribe because it really does help us out over here, and it also really helps us reach others in need of assistance with these topics. So today we will be starting our very first video on differential equations, and we're going to be going over the separation of variables method in order to solve for these differential equations given boundary conditions. So we have this differential equation shown here of y prime is equal to x to the third divided by y. And we are given that when we given the boundary condition of y of 2 is equal to 4. So what that means is that whenever we have our x variable of 2, the y equation pops out to be 4. So we need to actually find what that y equation actually is. So when you're using separation of variables, well, the name is there in the title where you want to separate your variables, having all your y's on one side of the equation, all your x's on the other side of the equation. So let's go ahead and start rearranging this differential equation to make that happen. So first off, you may know that whenever you see y or variable to a prime, what that means is that that is just the first derivative of that variable. So this will be y prime is equal to dy dx. So let's go ahead and just plug that in. So we have x dy dx is equal to x cubed over y. So what I'm going to do here is I'm going to take all my y's to the left side, all my x's to the right side. So in doing so, we take y over here. So we have y dy dx is equal to, well, x cubed divided by x gives me x squared. Well, now I can separate out my dy and dx's. So I end up, let's go over here. We end up with y dy is equal to x squared dx. Now that I have all my y's on one side, all my x's on the other side, and I have my dy dx completely separated out on one side of the equation for each, my next step would be to, let's integrate this. Integrate both sides of it here. So we're going to integrate with respect to y on the left side, and we're going to integrate with respect to x on the right side. So very simplistic integration here. So y dy becomes 1/2 y squared. And if any point you get confused or lost on the integration or derivations that we take in this series of differential equations, please check out the calculus videos that we have on our channel. So y dy becomes 1/2 y squared, and then x squared dx becomes 1/3 x cubed. And remember, when you integrate, you're going to have a constant every time you integrate. Well, instead of having two constants, we're just going to have one constant on the right side of the equation with the x's. Because if you have two constants, you can always combine them to be a single constant because, well, it's a constant number. It has no variable attached to it. So it doesn't really matter where you put it, but usually the best part or the position is with the x's. So this is what we have right here as our integration tool. Well, remember, we are looking for what is y? What's the y equation? So we're just going to take the 1/2 to the other side and then square root that side to get rid of the square of y. So when we have y by itself, it pops out to be this equation of the square root of 2 times x cubed over 3 plus c. So that is my y equation. Now, since we are given a boundary condition here, we can actually solve for what this c constant is. So let's go ahead and plug in our boundary condition to solve for this constant c. From the boundary condition of y equals 2, which I'm just going to filter this up here. Well, that means y of 2 is equal to 4, so that means the variable inside the y equation has to be equal to 2. Well, that's x. And then the resulting y equation would be 4. So let's just plug these in here. So we would have 4 is equal to the square root of 2 times 2 cubed over 3 plus my constant. Well, this is just easy algebra at this point. So you can just rearrange, move terms over and whatnot. So we end up with 16 is equal to 2, 8 over 3 plus c. And then I'm just going to go up here again to save some room. And then we're going to have 8 is equal to 8 over 3 plus the constant. Well, then the constant is equal to 8 minus 8/3, which gives me 5.33. And that is my constant. So what I can do is come down here and finish off my completed y equation with my known constant. So it would be square root of 2 times x cubed over 3 plus 5.33. And that is my answer. That is what the y equation has to be in order for this differential expression to be true, or this differential equation to be true. So you could stop there, but it's always, as with most stuff on this channel, if you've been watching, is that it's always a good practice to check your answer. Well, how do you check a differential equation answer? Well, you just take what you have for your y and plug it back in up here. So essentially what you're going to do is plug in the y equation right here wherever you have a y, and plug in the derivative of that equation, since this is y prime, the first derivative of the y equation. So let's go ahead and check this out. Actually, the check is a little bit longer than the actual first part of the problem here. So what we have is that we have x, y prime is equal to x cubed over y. So let's just go ahead and plug in our stuff here. We have x times the first derivative with respect to x of our y equation, which is the square root of 2x cubed over 3 plus 5.33. And then all of that has to be equal to x cubed over y, which once again is just the square root of 2 times x cubed over 3 plus 5.33. So what we're going to do is we're only going to concern ourselves with this side over here. Pretty much you want to concern yourself with the side that has the derivative expression in it, because this left side has to be equal to the right side. Well, the right side doesn't have any derivatives or anything that needs to be taken. The left side does. So that's what we're going to have to work on, and hopefully it pops out to match what's on the right side over here. So using or looking at this derivative right here, well, just keep in mind, remember, square root of x is x to the 1/2. So essentially what we have for this left part is x times the derivative with respect to x of 2/3 x cubed plus 10.67 to the power of 1/2. All I did was take the 2 in to each part here, making it 2/3 and 10.67, and then turning the square root into the 1/2. Now, looking at this, and if you've been through calculus before, and if you get confused on this part, just remember that we have calculus videos on this channel, because we are going to use the chain rule to solve for this derivative. And we do have videos going over the chain rule for calculus. If you just want to see more examples of this portion, or if you feel a little lost about the chain rule, just please check this out. So what we're going to do is we're going to set u is equal to the expression on the inside, 2/3 x cubed plus 10.67. And we're going to set f equal to u to the power of 1/2. So what we have going on here then is that this entire expression, I'm just going to scroll up here a little bit because it's going to be quite lengthy. So this entire expression, if we come all the way up here, df dx is equal to df du times du dx. Well, let's solve for each individual portion here. So du dx is equal to the derivative with respect to x of the equation of u, which is 2/3 x cubed plus 10.67. Well, this expression, when you solve out for it, the 10.67 completely disappears, and we are left with 3 times 2/3 x squared, which gives me 2x squared. Alrighty, and then the second portion of df du is essentially just the derivative with respect to u of that f equation, which is u to the 1/2. Really easy derivative to take here. It's just 1/2 u to the minus 1/2. Well, let's just go ahead and plug in the u equation, which was this original portion. So we have 1/2 of 2/3 x cubed plus 10.67 to the 1/2. Alrighty. So let's go down a little bit further here. So what we have going on here, because df dx is going to be this multiplied with this, and that is going to be our entire expression right here, becomes this, which is equal to this times this. So essentially what I have here is I have 2x squared from the first part, and then all of this pretty much goes in the denominator here because this is minus 1/2. So I have the 1/2, which is 2, times the square root of 2/3 x cubed plus 10.67. 2's drop out, and I'm left with x squared times the square root of 2/3 x cubed plus 10.67. Okie dokie. Well, remember, this is this entire expression that we just solved for. Well, we have to multiply by x. So x times that will be equal to, because it's essentially x times df dx for that left side of that equation. So what that's going to be, that's going to be x cubed over square root of, well, if we remove the 2 from both of those expressions, we have 2 x cubed over 3 plus 5.33. Oh, and look what that pops out to be. Doesn't that look familiar? Doesn't this right here match up with the right side of the original equation? Yeah, it does. You just have to do a little manipulation because we took out the 2 from the bottom. But yeah, it does. So my differential equation checks out with my original answer, which is right here of y equals the square root of 2 times that entire expression in there. So as I mentioned earlier, sometimes the checks will be much longer than the actual calculations of the answer for the differential equation, but it's always good practice to double check to make sure that you didn't screw up a step anywhere, because differential equations, a lot of potential to accidentally make a mistake somewhere. So I hope you found this video helpful. And if you want to see more problem solving of this variety, we will be uploading more differential equation videos. Please check those out on our channel when they're uploaded. Also, if you haven't done so already, please like this video, leave a positive comment below, and please subscribe to our channel because it really does help us out. Thank you for watching, and I hope you have a wonderful day.